After doing the physical and the chemical properties of the group 15 elements, now let us start the detailed study of the elements and the compounds of the group 15 elements. The first in this is the nitrogen. We know nitrogen is a homonuclear diatomic molecular species. It is prepared in lab by treating sodium nitrite with aqueous solution of ammonium chloride. Now, when sodium nitrite is reacted with ammonium chloride, what we get is ammonium nitrite and sodium chloride. This ammonium nitrite on its own decomposes to give nitrogen and water. So in lab it is very easily prepared by treating sodium nitrite with aqueous solution of ammonium chloride. Industrially, or we can say commercially, it is prepared by liquefaction of air followed by its fractional distillation, which leaves an oxygen and the other gases. So commercially it is very easily obtained by the liquefaction of air followed by its fractional distillation. It can also be obtained by thermal decomposition of ammonium dichromate. When ammonium dichromate is thermally decomposed, we get ammonia, Cr2O3 and water. Basically the dichromate ion oxidizes ammonia, nitrogen of the ammonia which is present in -3 state to 0. So this is how it can also be obtained like this. Pure nitrogen can also be obtained by the thermal decomposition of barium azide N3- ion. This gives you barium plus nitrogen. The same reaction can also be done with sodium azide, which on thermal decomposition gives sodium and nitrogen. So these are its general methods of preparation of nitrogen gas. Now let us discuss its properties. See, it's a colorless, tasteless, odorless gas which is very, very inert, as its bond order is 3 and the two nitrogen atoms are having 3 bonds between them, with each of them are having one lone pair. So it is very stable inert gas. That is why whenever we require inert atmosphere, we normally use as nitrogen. It doesn't react easily. Now, it is having very low boiling point and it is very, very stable gas. The reason because of the very strong triple bond. It doesn't react with the elements easily. It reacts with very few elements which are very reactive metals, and with mainly which are metals. And with metals it forms ionic nitrides. The examples are, it reacts with lithium and forms lithium nitride. It reacts with magnesium and forms magnesium nitride. All of which, when actually treated with water, gives ammonical smell as ammonia is formed. So this is what its basic property, that it reacts with very few elements because only very reactive metals can react with it. Then we all know it combines with hydrogen and forms ammonia as per Haber's process, the detail of which we will be doing just now after this compound, because after this nitrogen, because we have ammonia in the syllabus. Another interesting thing is, which proves its very high stability, is its oxidation. Nitrogen can be oxidized when heated with oxygen at around 2000 Kelvin, and then only it forms nitric oxide, which is possible only at such a high temperature. So these are all its basic reactions.